Topic G, using finding probability using the words and or. So let's look at the first question. A bag of marbles contains 2 green, 1 red, or sorry, 1 blue and 3 red marbles. Okay, so you've got 2 green, 1 blue, and 3 red marbles for a total of 6 marbles. The marbles are, if 2 marbles are chosen at random with replacement, which means they're put back in, what is the probability that the first will be blue and the second will be green? Well, the probability that the first will be blue is 1 out of 6, right? And the probability that the second will be green is 2 out of 6. And then to figure this out, all I have to do is just multiply my two numbers together. Whenever it's the word and, I have to multiply them together. So I end up getting 2 out of 36. That's my probability. Okay? What's the probability that they're both red? Well, the probability of the first one is red is 3 out of 6. Now don't forget, it's put back in. So the probability of the second one still being red is still 3 out of 6 because I haven't changed anything because I put it back in. So the answer to this is 9 out of 36. Okay? So let's look at question number 2. When tossing a die, what is the probability that the number is either a 2 or odd? So let's list out all the possibilities. When I roll a die, I could get 1, 2, 3, 4, 5, or 6. Now, is the number 1 either 2 or odd? Yes, it's odd, so it works. Does 2 satisfy this condition? Yes, because it's 2, and it says it could be 2 or odd. 3 satisfies because it's odd. 4 does not satisfy because it's neither 2 nor odd. 5 does satisfy because it's odd, and 6 does not satisfy. So the answer to this question is 4/6. Okay? Now, what is the probability of tossing a number greater than 4 or an odd number? So let's list out all the possibilities again. 1 works because it's odd. Okay? 2 does not work because it's not greater than 4 or odd. 3 works because it's odd. 4 does not work because it's not greater than 4, it's only equal to 4. 5 works because it's odd and it's greater than 4, and 6 works because it's also greater than 4. So the answer to this question is 4/6. All right. Now, when you have probability questions with when it says that things cannot be replaced, then you have to remember to subtract out your repeats, okay? So for example, number 4, from a jar that contains 3 white marbles and 5 green marbles, what is the probability of picking 2 marbles if the first marble is replaced in the jar and the second marble, before the second marble is picked? So the probability of getting a first marble being green is going to be 5 out of a total of 8. Now, the first marble is replaced. So after it's replaced, no matter what it was, there's still going to be 5 green marbles out of 8 total marbles. So the answer to this question right here is, sorry, the next part is also going to be 5/8. So my answer is 25/64. Okay? But sometimes it'll say that the marble is not replaced. So the probability of getting a marble that's green the first time is 5/8. And then the probability of getting it the second time, well, now you have 1 less green marble and 1 less marble total, so it's 4/7. So the answer to this is 20/56. Okay? Remember, if you're looking at the probability without replacement, the probability of each succeeding event is dependent on the event before it. So this probability changed because it's dependent on the fact that you took 1 marble out. Okay? So go ahead and try number 5. See how you do. Okay, so it says to find out the probability that both are blue without replacement. So there's 6 out of 9 marbles that are blue, okay? And then, pencils. The next pencil, the probability is going to be 5 out of 8 because I took 1 pencil out. So the answer to this question should have been 30/72. Okay? Go ahead and try number 6. Don't forget to press pause. Okay, so I'm going to list out all the possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay? So I'm going to list them all out, and I'm going to find all the numbers that satisfy what we want. It has to be less than 7 or prime. 1 is not prime, but it's less than 7, so I will include that value. Okay. 2 is prime and it's also less than 7, so I'll include 2. 3 is also prime and less than 7. 4 is less than 7. 5 is prime and less than 7. 6 is less than 7. 7 is prime. It's not less than 7, but it's still prime. 8 is neither less than 7 nor prime. 9 is neither less than 7 nor prime. Same thing for 10. 11 is prime, so it works. 12 does not work. So I've got 1, 2, 3, 4, 5, 6, 7, 8 possibilities out of 12, so the answer is 8 twelfths. All right, so now a basketball team is playing in a tournament. On one day of the tournament, they play 2 games. The probability of winning the first game is 2/3, and the probability of winning the second game is 3/5. What's the probability that the team will win both games? Well, the probability of winning the first game is 2/3, and the probability of winning the second game is 3/5. So the answer to this question is going to be 6 out of 15. Now, question B is a little bit trickier. Make sure you're paying close attention to this. What is the probability that the team will win at least one of the 2 games? So what I'm going to do is I'm going to list out all the possibilities, okay? So the possibilities, if I'm going to win at least one of the 2 games, I could either win the first game and win the second game, or I could win the first game and lose the second game, or I could lose the first game and win the second game, okay? Now the probability of winning the first game, we figured out, is 2/3. And the probability of winning the second game is 3/5. Now, whenever you have or, you're always going to add these numbers together. So I'm going to add all 3 possibilities together. So I'm going to say plus. Now, to find the probability of winning the first game, we already know that. That's 2/3. I'm going to multiply that by the probability of losing the second game. Well, if the probability of winning the first game is 3/5, then the probability of losing it is what's left over, which is 2/5. All right? So this is times 2/5. And then this right here is going to be plus the probability of losing the first game. Well, if the probability of winning is 2/3, then the probability of losing is the rest of it, which is 1/3. And I'm going to multiply that by the probability of winning the first game, which is 3/5. Okay? So then I end up getting, right here, when you multiply all of this together, this ends up becoming 6 out of 15. This ends up being 4 out of 15. And this ends up being 3 out of 15. So altogether, my final answer is 13 out of 15.